first area here is SCRT and usage data. Heard the story here recently told by Kathy Walsh at Share that when the original SCRT program was commissioned within IBM, it was the group development was told that it was going to have a 6-month life, and that was in 2002. So here we are 15 years later. It's been recently rewritten in Java, but still anyone who's used either IBM SCRT program is well aware that it's very good at telling you how many MSUs you use so that IBM knows how much to bill you, but it's not good at all at giving you the information that could help you to reduce that bill. So IntelliMagic Vision is designed to give you that information by displaying the various peak 4-hour rolling average values by product by billing month. It supports both the country multiplex pricing, which has a single peak across all CACs, and then separate peaks by CAC. And then there are drill downs directly into the rest of the product to show what workloads are actually consuming CPU during those peak periods and what address spaces are registering each product. So let's go ahead and demonstrate that. Here we see all the peak values for this billing month, the peak MSU values for each combination of processor and product, and the time when they occurred. So let's drill into that time period for this peak value here for CICS. And here we see now the top 20 values for this billing month. And so we can compare the values at the top with the peak with the other values during the month and see what kind of a difference there was, so that we know what kind of action we want to take in terms of managing that peak. Here also we see peak values for each product for the IBM products for the billing month, and again with the relative relationships we can see the degree to which we have configured LPARs to have a less expensive software product suite. Okay, so let's drill down now directly into this interval where this peak occurred so that we can understand what workload was running at that time period. And so we can drill down either by system, by workload, by service class. In this case, going to drill down by WLM importance level to see how much work was running at each of the WLM importance levels. So here in this example, during this and this is the 4-hour period that represented the peak for the month, 9 a.m. through 12:59 p.m. And we can see in this example that the work that was running was almost all WLM systems level or importance level 1 or importance level 2. Very little at the higher or the lower, whichever way you want to say it, WLM importance level. So there may not be much in this example, there may not be much opportunity to move work outside of this interval because it's likely time-critical work. We could also drill down and see this information at a system level for that specific period. Then we can again see this for any particular system. We can go all the way down to address space data to see what address spaces were consuming CPU during this peak period and understand, if we have options to manage that peak more effectively. Now, several great capabilities emerge from the fact that IntelliMagic Vision consolidates the usage data from the Type 89 records along with the address space Type 30 records. One good use case is to enable you to profile the workload using a product to assist in your efforts that you may be undergoing to try to optimize your software stack. In the case of IMS, there are separate MLC charges for separate components of IMS. So those are called qualifiers in the SMF89 records. So we'll drill into that, and here we see the 3 IMS qualifiers, and we can drill into that for any one of the particular components and see which address spaces are registering that component to see if we have options to maybe consolidate that work and minimize the software stack on one or more LPARs. Another use case for this type of data is to identify rogue address spaces that are maybe that are causing a product to show up as active and charge MSUs on an LPAR where that product was not intended to be active. If you've ever been involved in trying to track that kind of a situation down, even after isolating it to an SMF interval, it usually ends up involving trying to locate the proverbial needle in 1,000 lines of syslog. But here we can drill into the systems that are utilizing any particular product. So in this case, again, IMS, and we see that it's active on these two systems, and there's a lot of CPU time on each one. So then this is not a case where there was a rogue use. But if there was, we could again drill down on this system by job and see exactly which jobs were registering that product during whatever time interval. So again, immediately identifying, pointing to any workload that was active that was not intended to be on that system. And then finally, here is one more use case in terms of users of specific product versions. Under the legacy single version charge program from IBM, it allowed 12 months to complete the migration from one version of an IBM product to the next before you had to incur charges for both versions. So here we see in this example a very small amount of use for CICS version 5.3, and we could drill into that by job and see which jobs on each system are using that particular version. So in this case, it's identifying the progress of a migration, or in another scenario, it could identify stragglers still executing the old version of a product. So again, great visibility into the usage data, into the peak 4-hour rolling averages for the month to enable you to manage that effectively.